Thanks everybody for having me here. Thanks to the React Amsterdam team for allowing me and my team to come and visit and really learn from all of you about what everybody's trying to build today. My name is Richard. I work for AWS mobile team. I was part of two teams that launched a couple of big projects last year. One was a preview of a service known as AWS AppSync, which is a managed GraphQL service. The other that I was part of the team that kind of created from the ground up and launched was an open source library and project known as AWS Amplify, which was essentially kind of trying to standardize a way in the industry for JavaScript developers to interact with cloud services. And today, what I'm going to talk about is kind of a play on a couple of different talks that I've seen over the past year in the industry, which is something similar to like a slide that you've seen here. So, Kitsy's talk was very good right before this because many of you are probably familiar with like the hello world of GraphQL. So it usually goes something like this. You create some sort of a schema. Maybe this is using something similar to what you're seeing on the screen, which is schema definition language, or maybe it's writing it from scratch in JavaScript or TypeScript. And then kind of the basic boilerplate with GraphQL, right? Client defines the fields that it wants to come back to it, and boom, that stuff comes back to that client. That is actually not what I'm going to talk about today because there's tons and tons of videos about this on the internet, even AppSync ones from AWS. What I'm going to talk about today is what comes after Hello World when you're trying to do GraphQL at scale, and some of the learnings that me and my team found from working with customers and what people are trying to do day to day in their businesses, whether these are large-scale enterprises or startups or otherwise. And since we launched about 4 months ago, it turns out there's a lot of things that come after Hello World. It's very easy to just npm install the latest spec implementation of a GraphQL server on Express, but when you actually get into real-world use cases, you deal with things from scalability to DDoS to database management, just as like the basics. Then you start getting into all sort of things like, all right, well, it's interesting, but now I need to define kind of repetitive code 3 places. I need to define my schema, and then I need to edit these resolvers, and that's 2 places. And then I also need to, as Kitsy was saying, like define what queries I want to have on my clients. And now it's repetitive code all over the place. You get into all sorts of use cases around authorization, both coarse-grained and fine-grained authorization controls. You get into keeping up with the spec, offline support, real-time sync, logging, compliance, all of these things. And that's even before then you get to like what are kind of boilerplate use cases on the web when it comes to like uploading or downloading objects like videos and photos. So we released this service in the last week of November, first week of December. And the goal was to kind of get into the market to address some basic use cases around using managed GraphQL with real-time use cases as well as offline support. There were a few tenets, though, that we really tried to attack when it came to the previous year and development of this and working with a lot of people. One of those was not to just kind of hide some things behind an opaque data store that you as a developer couldn't control and manipulate. So we give you access to AWS resources in your own account. So give you access to Amazon DynamoDB, very highly scalable NoSQL database, Amazon Elasticsearch, and then you can essentially kick off triggers with AWS Lambda to interact with all sorts of other data sources that you want to do. We built in real-time and offline use cases, automatic sync, conflict resolution in the cloud, not just local callbacks on clients, and even a whole bunch of enterprise-level security features, and gave people the capability of doing things like row-level access for individual users, like I'm creating some sort of CMS or blogging app. Anybody can create or read blog posts, but only like the author of an individual item or something can edit or delete it, stuff like that. The kind of hello world with AppSync is pretty basic, and I took a little screen capture of this because I want to go into some other advanced demos. But you essentially go into the AWS console, you type in GraphQL into the search bar, and you create an API. Now, out of the box, we give you this sample schema that showcases a lot of the capabilities of GraphQL. So it sets up what's known as like an events app, which you could think is a regular pattern like blogs with comments. In this case, it's events with comments, like I want to meet up with my friends and then go out for drinks on Friday night and people can comment, looks great. It demonstrates relations. We give you some starter apps in React, React Native, also native apps in iOS and Android on this. Or alternatively, you can do what's on the screen right here, which is create a schema from scratch and essentially do code first or schema first development. So rather than create databases in the back end, You define your data model with GraphQL, which is kind of where we want the industry to go with some of these things. And then you can provision resources automatically in the back end. And our flow will wire everything up for you. There's no resolver editing. There's no need to wire up real-time communications with subscriptions. We automatically hook all of this up for you just in a couple of minutes and provision all of those database resources. So from there, now that you have a schema in place, and this is not a sped up video or anything like that, you can do some mutations like creating a post, or you can use our query editor, which is very similar to GraphOL, so it's got all the tooling and linting built into it to get your posts. So we'll even build in stuff in this, like you can see a list post operation to where we build in pagination using GraphQL connections. So you have all of those capabilities built in out of the box with this service. Cool, get some results. So the past 4 months since we launched this, what did we release in this timeline? Well, the first was some of those capabilities at reInvent. And that was the conference that we announced at in November. So real-time, pagination, aggregation, search, offline, all out of the box. We had a couple of interim releases since then. This was still under the guise of this was a preview release that we released to public. So we did the reverse flow of what I just showed you, which is you could create a DynamoDB NoSQL database and create GraphQL schema from that. This is another industry that we see another kind of trend we see the industry going towards in the future. So do things like inspecting the key schema on a database, figuring out what all the indices are, and auto-generating your common GraphQL operations. Another very popular thing that we've seen in production is this concept of turning GraphQL into a pub sub engine. So we introduced basically a way to have no data source into the system. And you could have out-of-band operations, like maybe somebody uploads an image to a bucket, and then there's a thumbnailing process that happens. And then after that, you kick off a mutation in the system, and then that does a subscription notification to out of all your clients. This is another area that we saw in practice that a lot of people did with GraphQL. We expanded to a bunch of new regions, added in unions and interfaces support to the service, resolver utilities, and a couple of interesting patterns that we found with object storage using S3 linking as well that I'll talk about. So what are some people building with a system like this? The first is offline data rendering. So the way that our client works is we have a plugin SDK that works with the Apollo client, and essentially all you have to do is just create an instance of our constructor, pass in your credential information. Now, we released a library as well, as I mentioned, called AWS Amplify that does everything from your signature version 4 signing routines, which is essentially a cryptographically secure way to sign messages using a 4-part HMAC over the network. But you just call like a simple declarative function like this, pass this to the Apollo constructor, and immediately we persist all of the data offline. So on web, that's going to be local storage. On React Native, it's going to be async storage, and we basically create it with the exact same interface. The way that Amplify library works is it's a very open standard that we released, but it's a category-based way of programming. So I want to do auth, I just call methods on an auth category, like register user, login user. I want to do analytics, I call some methods on that. Now, I've got a couple of things here highlighted in blue that I'm going to talk about more today. One is this pub subcategory, which we silently released a couple of weeks ago, and it allows you to do a real-time WebSocket connection using Amplify as well. The API category, up until today, you could probably guess what I'm going to talk about, just did REST APIs. I've got some announcements that I'll talk about at the end of this presentation to talk about how we expanded that as well. So images and rich content. This was another area that you hear all sorts of conversations. GraphQL is great, but what am I going to do? Base 64 encode every single one of my videos and throw them into a database? Clearly not a very scalable pattern. So the common mechanism that people do in the industry is store those records in a database like DynamoDB and then store the objects in object storage like S3. And what we allow you to do is, let's say you have like a user type like profile and it's got first name as a string, maybe age as well as an int. You can create this user-defined type known as S3 object with a bucket and key, and then do your mutations straight against that object, and we will essentially coordinate the referencing and pointers to an S3 object for you, both on the writes as well as the other side for the reads and the clients, so that our SDK will just send that up to the bucket and then stitch that data back together on the client when it comes back. Another thing, of course, because we added real-time capabilities into the system, is GraphQL subscriptions, becoming very, very popular in the real world because everybody needs everything real-time. And the way that we implemented this was using something very similar that Facebook talks about on GraphQL.org, which is an event-based system. And that means that a subscription notification to clients is the result of a mutation that you do to the system. Now, the way that we did this with AppSync and exposed it for people is you can effectively, since you've got both this none data source as well as a AWS Lambda endpoint, you can turn any part of your infrastructure into a real-time GraphQL endpoint. Because you could do a mutation, a Lambda function runs, interacts with maybe like an EC2 server or something else, and then the responses still go down to your clients. We're seeing this pretty popular in the industry as well. The other ethos that we stood by when we built this service was we wanted people to be able to start very cost effectively, like maybe it's weekend projects, maybe it's a startup or something else, and just use a single data source. And when their business graduates and they have more complex data needs, rather than re-implementing their entire backend or architecture because they hit some scalability concern, they can use GraphQL to swap in and out the implementations of certain data types. So for instance, you could start with something very simple like this, and then maybe when you want to add like search post capability in, you can stream data across from one of those data sources to your Elasticsearch cluster, and then it effectively looks like you have this Uber database on the back end with a combination of NoSQL and search capabilities. So just to demo this a little bit and show you what that might look like. I've actually got this stood up, and we exposed this a little bit as well now with some of the automatic CloudFormation support that's in AWS AppSync in our documentation. And you could see something like I might have a very easy blog post type system that's got IDs, author, title, and content. And I've got a put post operation that when I manipulate these two data sources, so you can see I've got a DynamoDB and Elasticsearch data source, what it'll do is it will stream data from one of those data sources over to another. So to start with, I'll do a list operation. This will come from my DynamoDB data source, and you can see I've got one blog entry in here. Now I'm going to do this add post operation, which, this is a dog on our team named Nadia. And Nadia might have her blog post is running in the park, playing fetch is fun. And that, again, did an atomic operation against your DynamoDB data source. But if I do my list operation, it's going to show both of those records now from my kind of scan operation on a DynamoDB table. But I can also do full text search, like fetch was actually what I put in this content here. And normally that would be a very difficult task to do if you just had like a REST endpoint wired up to a NoSQL database. But with a system like GraphQL in the front where you can mix and match data sources and stream data back and forth between them, now you essentially have built yourself a custom purpose-built database on the back end that's fronted by a standard query language. Some other things that we're seeing pretty actively in the industry that people are jumping into pretty heavily is all sorts of fine-grained authorization routines. Now, the way that AppSync works is when you kick off a GraphQL request, we thread identity information about the caller all the way down to the resolver when it invokes. So by threading all of this identity information as well as like the arguments that you're passing in and any of the context information like what's coming from the parent, you can effectively write conditional logic inside your resolver. So we have two modes of authorization. One is what we call kind of coarse-grained authorization, which is setting permissions at the resolver level, or rather at the schema level. So this could be classical AWS IAM type stuff, or it could be JWT token style, where you basically use a directive on your schema and say, these specific logical groups in a JWT token that comes in an authorization header, they have rights to invoke these specific resolvers. Then we have what's known as fine-grained authorization, where we thread all of that information through to your resolver, and you can do conditional statements like, if user is this, or the current username, allow it to run, otherwise it's an unauthorized method. But what's pretty interesting is what we didn't expect, and we saw quite a bit, is when people use GraphQL, since essentially it's a graph and you can walk the application graph, when you do stuff like a query that I've got in this picture here, I can essentially nest resolvers, and they can pass context through from one parent to another. So for example, if I wanted to write an app like friendship, so only allow people to see my data if they're friends with me. Well, the classical way that you would build this in database systems is you would use one NoSQL database table to have like a primary key of the friend and then a hash key, or a primary key of the user and a hash key of the friend that's trying to access it. If that record exists, well, you're clearly friends. If not, that person's not friends with you. And so now that you use GraphQL, you can have one top-level resolver query that data, pass that information down to a child in the context source, do a conditional if statement. If that exists, allow it to return data. If not, return it in an unauthorized method. So you can do a lot of really powerful things with just some raw primitives of using something like AppSync as well as just the raw GraphQL capabilities that you're given. This would traditionally be pretty difficult in a REST-based system. Now, additionally to this, these are kind of what people have been building the past 4 months or so. What else comes after Hello World? So when we released this in November, we released this as a preview service, but I'm pretty excited to announce that today, AppSync actually is officially a general availability service that you can use for any of your production apps. Not only are we announcing general availability, but we're going to announce some new features that you can use as of today along with this service. So the first is, again, talking about what people actually do after Hello World, what they're trying to build in the real world. I mentioned earlier that there's a lot of complexity when it comes to editing resolvers and even kind of seeing what they're going to do in the real world interacting with your data sources. We added some new capabilities in around both unit testing and integration testing flows of your resolvers, in that we can mock out context inside of a resolver and just essentially see what it'll be on a request before it goes to a data source, as well as what mocked context would be when it comes back from a data source. The other thing that we did is we leveraged another service of AWS, which is known as CloudWatch, and this gives you full logging of requests as well as metrics that you can set on how good your API is doing. And we can do a live debugging and streaming of requests over to your GraphQL endpoint as you're invoking them against a service. So you can essentially get both unit and integration tests within the system. We added CloudFormation support, so you can do full automation of building different APIs for different clients that you're working with. And the other thing that we did is we added resolvers onto subscriptions. So some of those fine-grained authorization routines that I was talking about before, previously they were only available on queries and mutations. Now they're available at connect time on subscriptions as well. This is another one of those what comes after Hello World things that you see in anger when you're dealing with the industry. Because a lot of people want to build chat apps, but they don't want to just build chat apps that you can't do private rooms or one-to-one conversations or that people can sniff the network. Instead, now you can actually do runtime authorization checks on a resolver when somebody's going to subscribe to data, and only if they've got access to maybe a specific chat room or messages meant for them are they able to get access to this data. A couple of other things. One of the things that we've been seeing more and more is the blending of mobile web, mobile development, and IoT use cases more and more. And you might have seen this earlier. There was a session on AR and VR that Nader gave. There's also more and more sessions that happen at React conferences of people like interacting with TVs or smart fridges and stuff like this. And we're seeing this a lot as well, which is people using GraphQL for like car sensors or weather stations and stuff like this. And then they want on phones or web or tablets to be able to display some of this data in real time. So what we added was batch capabilities on individual resolvers for writing and reading to DynamoDB, so that you can essentially, rather than doing multiple uploads of batch information or reading data, you can just send one specific payload that goes over the network, and that will do a batch write to one or multiple tables simultaneously in a single GraphQL request. And the same thing with a read. So I'll demo this in just a couple of minutes. Some other stuff that we're announcing today is we've now extended the Amplify library that I mentioned earlier to have full GraphQL support. So from a single library, you can do all of these secure authentication and authorization mechanisms. You can do object storage, and you can do both REST and GraphQL operations for queries, mutations, and subscriptions all through in one library that you can import. We've added capabilities to our AWS mobile CLI to scaffold all of this up from scratch. So you can just run kind of 1 or 2 commands, and it'll build a fully functioning GraphQL API, even doing CI flows like synchronizing all of your schema back and forth when you edit locally on the client. And the other thing that was also, another one of these things that happens in production scenarios is going through all of the different auditing and compliance mechanisms. So as of today, you can now run HIPAA compliant workloads on AppSync in production along with the GA functionality. So that's a lot of things. Let me see if I can demo a couple of these. So I talked about this test debug workflow that we have. So now when you're editing our resolvers, and our resolvers, what they are is they are a mixture of this language, this templating language known as Velocity that allows you to basically write a mixture of JSON and some DSL, but we're able to execute it in a deterministic amount of time so that we know that your queries are bound, that you can scale appropriately, and not bring down your backend database. But what's a little bit difficult about that is mocking out the exact context and knowing what the information from a GraphQL query is going to be ahead of time. So now you can basically pass in a mock context. We will actually infer from the GraphQL AST what both your arguments would have been going in as well as the request coming out. So you don't even need to go back and forth and plug in all of this information. We then will allow you to go into our query editor and do a full integration test, and then we'll stream all of the information over from the logging, including the individual GraphQL type and field level execution summary to your console. Then, of course, on some of this, we have this batch operations that I talked about. So this is single or multiple tables at the actual GraphQL leaf level of invoking a single resolver. And you can extend it further by not just doing it reads or writes to multiple tables, but you can do custom error handling. Because if you think about it, if I'm dealing with different logical tables or even logical areas of my GraphQL API, I could actually have part of it succeed if it's a batch operation, and then other stuff fail, like maybe it's an authorization error. So you can do partial responses or unprocessed key information and send that back to the client so it can make the proper decision as well. We also preserve order, and then we give you a bunch of ways to do delete operations on these as well. So what does this look like in Anger? So I did that demo before from Oregon, so I'm going to go over to Ireland just to kind of show some multiple schemas that we have in different locations. And this demo is pretty interesting because not only does it show batch operations, but it shows different things like unions or interfaces on your GraphQL schema. So let me make this a little bit bigger so you can see some more. In this example, what I've actually got is, to show you, I have two tables, one for location information and one for sensor information. Like I mentioned, this is great for IoT use cases. And let me clear all of this out to kind of begin with. So imagine like I've got a bunch of weather stations or smart cars or something else, and I want to get both the temperature as well as the location information like latitude and longitude from all of them. So because this is a very common pattern for sensors, right? Latitude and longitude, maybe it has a sensor ID and a timestamp on both of them. I can use a GraphQL interface. So my interface is going to be sensor reading, where I've got a sensor ID and a timestamp. And then for my temperature readings, I'm going to implement that interface and also add because it's a temperature, a float value. For my locations, I'm going to implement that interface, and I'm going to give it a latitude and longitude. From there, it's very simple. I want to record some readings in bulk, so I'll use an array. I want to delete some readings in bulk, use an array, and I want to get some readings by an individual sensor ID and timestamp. So if I come back over here to my queries pane, the first thing you'll notice is down here, I now have this logs capability. So I'm going to open this up a little bit. And this is what will allow me to stream over CloudWatch logs. And I kind of cheated ahead of time, and I have some of these. So I'm going to do a mutation here. It's going to add a few of these sensor readings in. Let me make this a little bit bigger so you can read it. Right, so I'm going to record some of these readings using that interface. It's pretty clean, right, if you look at GraphQL here. I'm going to send a whole bunch of sensor ID readings with timestamps in. AppSync also supports a bunch of DSL helpers in our resolvers, like server-generated timestamps and stuff like that. And if I go ahead and invoke this, it actually went ahead and wrote the records to the database. What's happening over here is we'll start tailing the logs, so they take a couple of seconds to come back. I could also click this little link and open up the live logs in the CloudWatch console, and it'll show it streaming in here, so you can see all of my execution readings. But the data is actually coming back streamed live. So if I had an error or something, I could live debug this and see like what the resolver ARN was. I could see information like if I had any errors here on my source or the parent. I could see the overall execution time. And again, these are resources in your own account. So if I come over here, just a regular DynamoDB table, that all worked from doing a batch upload. Now I want to maybe do a delete of some of that information. So this time I've got a mutation. I'll add this in here, and this specific record with a date and a time, I'm going to delete simultaneously from two separate tables. So I go ahead and delete this. Again, it's going to stream the logs over. But if I look at my records, I had 5 before in both tables. Refresh this, it's only 4, right? And similarly, I can go over to my tables and do some queries. And this will bring back my data as well. So pretty powerful information here from literally just having something that is a very simple schema that out of the box will handle all of the scalability on the back end for writing and reading to multiple tables in just very simple requests like this. And of course, this can all be hooked up to GraphQL subscriptions. So while maybe my sensors or other data are sending this data in bulk to the back end, all of your mobile and web apps can get updated in real time using those WebSocket connections. So a couple of more announcements before I end today on some stuff that we've integrated is, I mentioned we've also extended our Amplify category for an easy programming model. And Kitsy kind of talked about this earlier. Now, we will continue with our support to offer SDKs and plugins for the popular GraphQL clients that a lot of our customers ask for. So as you saw earlier, we integrate with Apollo. We've actually got more plans for even simplifying the implementation and integration with Apollo in the future. But we also know, similar to what Kitsy was saying, that there's a lot of customers that really want a simplified GraphQL interface. They don't want all of the mechanisms for caching and everything else, and they just want to get started very quickly with queries, mutations, and subscriptions. So what we allow you to do is basically use the API category of the Amplify client and pass in a single configuration. Now, it's worth noting this is a generic GraphQL client, so even though it works out of the box with AppSync, you could use this simplified client for other GraphQL endpoints as well, or even build like a GraphQL endpoint of your own, like on an EC2 server, or maybe using some of the serverless technologies. What the API looks like is very simple, so very similar to if you've ever seen Urkel or something like that, where we have an extension of the API that you do just an API.GraphQL, and you can pass in a query, and you can pass in a mutation keyed by query as well. In those cases, it's just going to send you back a response, so you could use something like async await on it. In the case of a subscription, we will use the exact same prototype for the function, but return an observable for you that you can basically call next or on complete or on error for. We also, of course, to stay popular with all the things that are trending and everybody's using, is we offer a React component that you can use render props on. So you can, just like Urkel, have a connect component, pass in a query in it, and use it within all of your different components. So these were basically the things that I wanted to come here and talk about how people are using GraphQL in production today. I'd recommend you to check out the service if you're interested in really building some of these things in production. Otherwise, I have a team of people that are at the little AWS booth behind the big screen that we can talk to you one-on-one later today. Thank you.